Aristotle and Copernicus each presented groundbreaking models of the universe that reflected the scientific knowledge and philosophical beliefs of their eras. Aristotle's Earth-centered or geocentric model positioned Earth as the fixed center of the universe, with all other celestial bodies, such as the Sun, Moon, planets, and stars, orbiting it in perfect circular paths. This model, rooted in ancient Greek philosophy, was widely accepted for over 2,000 years and aligned with both observational evidence and the belief in Earth's unique central role in the universe. In the 16th century, Copernicus introduced a radical new theory, a sun-centered or heliocentric model, unlike Aristotle's geocentric view. Copernicus placed the Sun at the center of the solar system, with Earth and other planets orbiting around it. This shift redefined astronomy by challenging long-held beliefs and simplifying explanations for phenomena like retrograde motion, which Aristotle's model struggled to explain. Copernicus's heliocentric theory paved the way for modern astronomy, laying the foundation for future discoveries that will deepen humanity's understanding of the universe. Aristotle was born on 384 BC in Stagira, Greece. He was a Greek philosopher and polymath, which also developed a philosophical framework for science, laying groundwork for future thinkers.
Aristotle's geocentric model. Aristotle's model placed Earth at the center of the universe. Earth was surrounded by the moon, planets, and stars, which move in concentric circles. These celestial bodies move in perfect uniform circles, reflecting a belief in an ordered universe. Aristotle's model are also celestial bodies were made of an unchanging substance called ether, which Aristotle considered incorruptible. This model fit observed phenomena at the time but struggled to explain retrograde motion and brightness variations in planets.
Now, let's move on to the limitation of Aristotle's model. Retrograde motion is the Aristotle's model that could not expedite why planets sometimes appear to move backward in the sky. Everyone, imagine you have a toy car truck and you think that every car on it should only go forward, never backward. But sometimes a car on the track does go backward and you don't know why. This is like how Aristotle, a smart person from a long time ago, thought about planets. He thought they always move forward in the sky, but every so often planets like Mars looked like they were going backward, and his ideas could not expedite why. Now, planetary brightness is the aberrations in brightness were inconsistent with the perfect fixed celestial model. I want you to imagine a lamp that should stay the same brightness when you're in a room. But imagine if every so often the light got brighter nor dimmer without anyone touching it. Aristotle thought that stars and planets should always stay the same brightness, but planets like Venus sometimes got brighter or dimmer. His ideas didn't have a way to expedite this change. For static universe assumption, it is the Aristotle geocentric theory assumed an unchanging universe, limiting its ability to explain observable inconsistencies. Think about your bedroom always staying exactly the same. Same toys in the same place, same color on the walls, forever. Likewise, Aristotle thought the universe was like this, never changing. But in real life, things in space do change, like stars moving or things appearing and disappearing. His model wasn't able to explain a changing sky. But later on, another thinking named Ptolemy added some extra loops and twists to the model, like adding more tracks for the cars. to try to explain these things, but it made everything more complicated and didn't really solve the problems completely. Now, let's have a little background about Copernicus. Copernicus, born on February 19, 1473 in Turin, Poland, a Polish mathematician, astronomer, and a Catholic cleric. Kilala siya for heliocentrism, quantity theory of money, and Gresham-Copernicus law. For further discussion about Copernicus, that will be delivered by Justin.
Copernicus' heliocentric model. Copernicus proposed that the Sun, not Earth, was at the center with planets orbiting around it. This model explained retrograde motion as a natural result of Earth and other planets moving at different speed in their orbits. Copernicus' model removed the needs of complex epicycle by reordering the planets around the Sun. His 1543 book on the revolution of the heavenly spheres detailed this heliocentric theory and restructured the known universe. This heliocentric model suggested that the Earth was not unique, challenging the theory of an Earth-centered universe. Why Copernicus' model works? By positioning planets in orbits around the Sun, Copernicus showed that retrograde motion was an optical illusion due to Earth's movement. His model placed planets in a specific order: Mercury closest to the Sun, Saturn farthest to the Sun, giving consistent explanation for observed distance in periods. The model allowed for simpler mathematical calculations to predict planetary motion, agreeing better with observed data. Copernicus assumed circular orbits, which later astronomers like Kepler found to be slightly elliptical.
So let's proceed to the comparison of two models, which are the Aristotle and Copernicus model. To summarize the major differences between Aristotle and Copernicus model, Aristotle's geocentric model placed Earth at the center of the universe with celestial bodies moving around it in perfect circle, relying on the notion that the heavens were unchanging and permanent. This view not only aligned with the ancient Greek philosophy but also with religious belief that placed humanity at the center of creation. Copernicus' heliocentric model, on the other hand, proposed that the Sun was at the center, with planets, including Earth, and also orbiting in it. Unlike Aristotle's ideas of perfect static circle, Copernicus' model eventually led scientists to see planetary fat as slightly elliptical, thanks to the later observation of astronomers like Kepler. This shift in focus from philosophical perfection to empirical accuracy was revolutionary, as it opened the door to science based on observation and testable hypotheses. And with Aristotle models, the universe was static and complete, while with Copernicus model became more dynamic. Copernicus effectively denoted Earth from its unique central position, making it one of several planets. This was a major philosophical and scientific shift because it suggests that our planet in the cosmos was not as unique as one believed.
Copernican models influence astronomy. Kepler refinements. Kepler used Copernican heliocentricity as a base, discovering that orbits were elliptical, not circular. Galileo's observations. Galileo's telescopic observations supported Copernicus by showing that Jupiter had moons, proving not everything orbited Earth. The heliocentric model marked the beginning of observational astronomy and data-driven science. Copernicus' model influenced the scientific methods of astronomers and remains foundational in astronomy. The transition Aristotle's models to Copernicus' heliocentric theory explains the importance of revisiting and revising the scientific models. Copernicus' work shows how new ideas can emerge through the revaluations of existing observations. This shift illustrates the development of astronomy from basic observational methods to a more mathematical, precise calculations. While Aristotle's geocentric model established an early framework for understanding the cosmos. It was Copernicus' heliocentric models that transformed astronomy into a precise mathematical science. The transitions Aristotle to Copernicus represents a fundamental shift in scientific thinking, marking the beginning of the scientific revolution and setting the stage for discoveries that continue to shape our understanding of the universe today.